Hello, students. In this section, we're going to talk about the graphs of sine and cosine functions. From the previous lessons, you have learned that the sine and cosine values actually correspond to the y and x coordinates of a point on the unit circle. The cosine correspond to the x coordinate and the sine correspond to the y coordinate. In this section, we're going to see if we graph these points, the coordinate values of these points, then how does the graph look like? So if I graph the x coordinate of some common angles, then I will get the graph of cosine. And if we plot the y coordinate, which is the sine value of the points or the angles on the unit circle, then I will get the graph of sine function. So let's first look at the graph of a sine function. So I have put here a table, input-output table of values in which the x correspond or x represent the angles, some of the common angles, and the y represents the sine values of those angles. As we all know, sine of 0 is 0. Sine of pi over 6 is half, which the decimal value would be 0.6, zero point 0.5. I'm going to write down the value under. Pi over 4, sine of pi over 4 is root 2 over 2, which the decimal value is about 0.707. We're going to use these decimal values just to make graphing easier for us. We know that we always emphasize knowing the exact values, but this is just a matter of plotting points, and I need to know the decimal approximation in order to plot the points. Sine of pi over 3 is root 3 over 2, which is approximately 0.866. Sine of pi over 2 is 1. And this again repeats in the second quadrant. Sine of 2 pi over 3 is also 0.866. Sine of 3 pi over 4 is 0.707. And sine of 5 pi over 6 is half, or 0 0.5. I've already shown here the graph of how the graph of these points would look like. But if you look at these dots, I have these dots correspond to the values in the table. This is 0 comma 0. Sine of 0 is 0. This point is sine of pi over 6, which is half. This point right here is sine of pi over 4, which is 0.707. As you can see, is approximately 3/4 of the way from 0 to 1. Sine of pi over 3 is about 0.866, and sine of pi over 2 is 1. And then 2 pi over 3 is 0.866. 3 pi over 4 is 0.707. 5 pi over 6 is half, and sine of pi is 0. And if I continue this trend, if I plot the points from the third quadrant and the fourth quadrant, I will see the second half of this wave. So this is the graph of a sine function, and you know that this trend will continue because you can go around the circle and have talk about as many angles as you want. And if you go clockwise, then you will have the negative angles, and those sine values will kind of go in the same pattern. So this is the graph of a sine function. How we can quickly identify the graph of a sine function is that sine of 0 is 0. Kind of it goes through the midline, and the midline is the line about which this graph is oscillating, going up and down. We will talk about different characteristics of this graph. Right now, you can see that it's a wave-like graph. Let's look at the graph of a cosine function, and then we will talk about the common characteristics between the sine and cosine function. So I have down here the table values for the cosine for these common angles. Again, I just took 0 to pi, but I will, we can see that this trend will continue. How the cosine is different than sine, we know that the cosine of 0 is 1, cosine of pi over 6 is 0.866, cosine of pi over 4 is root 2 over 2, which is 0.707, cosine of pi over 3 is half, cosine of pi over 2 is 0, and then you can see in the second quadrant cosine values are negative, and then they will just be repeating. 0.7, negative 0.707 for 3 pi over 4, negative 0.866 for 5 pi over 6, and negative 1 for pi. And as we have plotted these points right here, you can see that the cosine function didn't go through the origin. It actually started from the maximum value, which is 1 in this case. And as I plot these points, I got this uh, half of this wave. And if I continue in the third and fourth quadrant, I will have this other half of the wave. Again, this will continue. This trend will continue as I plot the negative angles. Also, if I continue the positive angles, I go around the circle again, this trend or this pattern will continue. Another interesting illustration I want to show you is on GeoGebra. So let's look at the graph of a sine function, and you can see I'm going to first come up here and then I will start tracing. So as I go around the unit circle, the graph that you see on the right-hand side is actually tracing all of the sine values for these angles. And this is pretty neat because you know that your angles, what we talk about are the common angles, but there are infinitely many angles that you can have. And then this graph is a continuous graph. It's going to keep plotting all these sine values. I'm going to go around the circle once and have the one full cycle of the sine function. And let's look at the cosine now. The cosine, I'm going to start, actually, I'm going to take off the sine and then do the cosine graph. This is how my cosine graph is going to look like. You can plot both of them at the same time, and it will be pretty neat to see the commonalities and differences between the two. Okay, so like I said, if I had continued, which I can, this would just keep going. This looks like it's only graphing from 0 to 2 pi. It kind of is designed this way, but if I keep going around the circle, this graph will continue. And this will also not show me the negative because it's the way it's been set up. It's only set up from 0 to 2 pi. So what we called a one cycle is actually called the period of a sine and cosine graph. And as you noticed, they both have a period of 2 pi. Cosine graph and sine graph both complete one cycle in 2 pi. As you can see from 0, it came back to 0 at 2 pi. And same thing with cosine. From starting at the maximum value of 1, it comes back to that maximum value of 1 at 2 pi. So one thing that we understood from the sine and cosine graphs is that their period is 2 pi and that they're continuous in nature, and they're also periodic in nature, which means the pattern repeats. You also can see that both have a maximum and minimum value of 1 and -1, so that determines the range of our sine and cosine functions. So right here, I have shown you the period of 2 pi. The top one is a sine and the bottom is a cosine. This also can show you the symmetry of the graph. If you look at the sine graph, it is symmetric about the origin. Like if I rotate this graph, then it's going to just land on itself. If I rotate it 180 degree, this part, this um, kind of the peak that you see will land on this bottom one, and the bottom one will land on the top one. So they will just kind of look the same. So we call the functions that are symmetric about the origin as odd functions. So sine functions are odd functions. Another way to write that or represent odd functions is that the sine of the negative angles are negative times the sine of the angle. What this means is, for example, if I see sine of pi over 2 is 1, then sine of negative pi over 2 is -1. Okay, so this is a representation of sine being an odd function. And as you look at the cosine function, they are symmetric about the y-axis. As if, like if I fold it or cut it through the y-axis, you could see that I have the same graph on both sides of the y-axis. Any functions that have this symmetry about the y-axis are called even functions. So cosine functions are even functions, and what this means is that cosine of the negative angles are same as cosine of the positive angles. As you can see, for example, cosine of pi is -1 and cosine of negative pi is also -1. Cosine of pi over 2 is 0 and cosine of negative pi over 2 is also 0. Okay, so this means cosine functions are even functions. So let's kind of summarize the characteristics of sine and cosine graphs. They both are periodic functions with a period of 2 pi. The domain for both is all real numbers, or negative infinity to positive infinity, and the range is between negative 1 to 1, and negative 1 and 1 are included. Sine functions are symmetric about the origin, so they're odd functions, and cosine functions are symmetric about the y-axis, so they are even functions. In the next video, we will talk about different transformations and how we determine the graph with all these transformations that happen to our functions. So stay tuned. Thank you.